Number 5.
Unlike a decade ago, United States is no longer the sole designer of stealth fighters. Russia and China has taken concrete steps in this direction. Chinese Chengdu J-20 has some stealth features, and Shenyang J-31 has been designed from grounds up keeping in mind stealth characteristics. Russian PAK F A is considered to be most potent competitor against F-35 and F-22 Raptor. The aircraft will be the first operational aircraft in Russian service to use stealth technology. On the other side of the table, the Russian S-400 and upcoming S-500 air defense system is known to have radars capable of detecting stealthy aircrafts. In this video, Defense Updates provides viewers with an insight on how USA intends to nullify the Russian and Chinese stealth technology.
Number 4.
It is the physics of longer wavelength and resonance that enables very high-frequency and ultra-high-frequency radar to detect stealth aircraft. UHF band radars operate at frequencies between 300 MHz and 1 GHz, which results in wavelengths that are between 10 cm and 1 meter long. Typically, due to the physical characteristics of fighter-sized stealth aircraft, they must be optimized to defeat higher frequencies in the Ka, Ku, X, C and parts of the S bands. There is a resonance effect that occurs when a feature on an aircraft, such as a tail fin tip, is less than 8 times the size of a particular frequency wavelength. That omnidirectional resonance effect produces a step change in an aircraft's radar cross-section. Effectively what that means is that small stealth aircraft that do not have the size or weight allowances for 2 feet or more of radar-absorbent material coatings on every surface, are forced to make trades as to which frequency bands they are optimized for.
Number 3.
Till now VHF and UHF radars could not generate a weapons quality track, or in other words, are unable to guide a missile onto a target. Poor resolution in angle and range has historically prevented these radars from providing accurate targeting and fire control. However, electronic scanning and new signal processing techniques have mitigated those shortcomings to an extent. And there are other techniques in development, such as linking multiple low-frequency radars via high-speed data links, which is enabling those radars to generate weapons quality tracks. The Lockheed Martin E-2D Advanced Hawkeye's central feature is the APY-9 UHF band radar. The radar is powerful hybrid mechanical, electronically scanned UHF band sensor.
Number 2.
The radar will be able to tie into the U.S. Navy's state-of-the-art Naval Integrated Fire Control, counter-air battle network and will operate in 2 ways. 1. From the air, APY-9 radar would act as a sensor to cue Raytheon AIM-120 air-to-air missiles for Boeing F-18 Super Hornets and F-35 fighters via data link. 2. From the sea, the APY-9 would also act as a sensor to guide Raytheon standard SM-6 missiles launched from Aegis cruisers and destroyers against targets. In fact, the U.S. Navy has demonstrated missile shots using the E-2D's radar to guide SM-6 missiles against over-the-horizon targets, which by definition means the APY-9 is generating a weapons quality track.
Number 1.
The technology would be able to detect aircrafts like the Chengdu J-20, Shenyang J-31, Sukhoi PAK F A, and indeed the United States' own Lockheed Martin F-22 Raptor and tri-service F-35 Joint Strike Fighter. Only very large stealth aircraft without protruding surfaces, like the Northrop Grumman B-2 Spirit or the forthcoming long-range strike bomber, will be able to defeat this radar. USA, having been in the forefront of stealth technology implementation, is continuing to work towards maintaining an edge over its rivals in this technology.
Thanks for watching. Subscribe for more videos like this. Hit the like button if you find the video interesting. Kindly provide your feedback in the comment section, this will help us improve.